What if I told you that the building you're staring at right now, that massive glass and steel tower scraping the clouds, almost certainly started as a hole in the ground deeper than a 10-story building? Most people walk past skyscrapers every single day and have absolutely no idea that what's happening beneath their feet is just as jaw-dropping as what's soaring above their heads. Today, we're going underground, up into the steel skeleton, and all the way to the top, to break down exactly how humans build the tallest structures on Earth. And trust me, by the time we get to how they stop skyscrapers from swaying the wind, your mind will be completely blown. If you're new here, hit that subscribe button right now, because we cover exactly this kind of deep dive content every single week. Drop a comment below telling me the tallest building you've ever been inside. I read every single one. The planning phase, years before a single brick is laid. Here's something most people don't know. Before any construction begins on a skyscraper, teams of engineers, architects, geologists, and city planners can spend anywhere from 2 to 5 years just in the planning phase. In 2026, digital modeling technology has taken this to a whole new level. Engineers now use what's called building information modeling, or BIM, which creates a full digital twin of the entire skyscraper before a single shovel hits the ground. Every pipe, every beam, every electrical wire is mapped out virtually first. This means potential problems that used to cost millions to fix mid-construction are now caught on a screen before they ever happen. The soil beneath the site is also tested obsessively. Teams drill deep core samples to understand exactly what the ground is made of, because whether you're building on bedrock, clay, or sand completely changes everything about how the foundation must be designed. The foundation, the part you'll never see, but everything depends on. This is where it gets wild. For a major skyscraper, the foundation can go as deep as 30 meters underground. That's roughly 100 feet, just to anchor the building securely. Workers dig what are called caissons, massive cylindrical shafts bored into the earth, which are then filled with reinforced concrete. These caissons transfer the enormous weight of the skyscraper down into the bedrock far below street level. For context, the foundation of a modern 100-story tower can weigh more than 200,000 tons before the actual building even begins going up. In cities built on soft ground or near water, like Shanghai or Dubai, engineers use a technique called a floating foundation or raft foundation, essentially creating a massive concrete slab that distributes weight so evenly the building sits on the soil the way a boat sits on water. Without a perfect foundation, nothing else matters. This single phase can take over a year by itself. The steel skeleton. Speed that will surprise you. Once the foundation is set, the steel structure begins rising, and this is where construction gets almost hypnotic to watch. In 2026, prefabricated steel components are manufactured off-site with robotic precision and delivered to be assembled on location. A well-organized crew can add an entire new floor to a skyscraper roughly every 3 to 4 days. The steel columns and beams are bolted and welded together to form a rigid core, typically a central reinforced concrete shaft that runs the full height of the building. This core houses the elevators and staircases, and it acts as the building's spine, providing the primary structural stability. Around this core, the floor plates extend outward, supported by the outer steel frame. Every single connection point is checked, rechecked, and signed off by structural engineers on site. One compromised joint at floor 20 could have catastrophic consequences at floor 80. The curtain wall, giving the building its skin. What most people think of as a skyscraper's exterior, that iconic glass and metal facade, is actually called a curtain wall, and it is an engineering achievement in itself. The curtain wall is not load-bearing. It hangs off the structural frame like a skin, protecting everything inside from wind, rain, temperature extremes, and sound. Modern curtain wall systems installed in 2026 use triple pane glass with built-in solar coatings that can reduce a building's energy consumption by up to 40% compared to older designs. The panels are typically manufactured in massive off-site factories, shipped in and craned into position. Installing the curtain wall on a major skyscraper involves hundreds of workers and thousands of individual glass panels, each one fitted with weatherproof seals and thermal breaks to prevent heat transfer. The wind problem. How engineers keep skyscrapers from swaying. Here is the part one promise you. Skyscrapers move. All of them. A 100-story building in a strong wind can sway nearly a meter at its top floor. Left unchecked, that movement would make the building feel like a ship in a storm and eventually cause structural fatigue. The solution is something called a tuned mass damper. It's essentially an enormous weight, sometimes 800 tons or more, suspended near the top of the building on giant hydraulic shock absorbers. When the building sways one direction, the damper swings the opposite way, counteracting the motion. Taipei 101 in Taiwan has one that weighs 728 metric tons and is visible to visitors inside the building. In 2026, newer designs use active damper systems where sensors detect movement in real time and computer-controlled hydraulics respond within milliseconds. It is literally a building that can feel itself moving and correct it. The final stretch, interior fit-out in vertical cities. With the structure complete and the skin on, the interior fit-out begins, and this phase reveals just how much a skyscraper is really a vertical city. Separate crews work on plumbing, electrical systems, HVAC, fire suppression, elevator installation, and interior finishing, all simultaneously on different floors. A major skyscraper might have over 20 elevators, hundreds of kilometers of electrical wiring, and a dedicated water storage and pressure system, because standard city water pressure can't reach the upper floors. In 2026, smart building technology integrates all of these systems into a central AI-driven building management system that monitors energy use, air quality, temperature, security, and elevator traffic in real time, automatically adjusting to maximize efficiency and occupant comfort. From a hole in the ground to a tower touching the clouds, the process of building a skyscraper is one of the most complex coordinated achievements in modern human civilization. And the next time you look up at one, you'll know exactly what went into putting it there. If you found this video valuable, share it with someone who would love it. And check out our next video on the world's most ambitious construction projects currently underway in 2026. See you there.